So our lesson is 2.3, solving for a variable. Your EQ is how do you rewrite formulas and literal equations. So when we talk about mathematical formulas, these are types of literal equations. And a literal equation is defined as containing two or more variables. Okay, so there's lots of literal equations that show up in math and science and engineering. There's an example here shown. We have a rectangular prism where the length is labeled, the width and the height. A literal equation or a mathematical formula for that situation for volume is capital V equals L times W times H, length times width times height. And it's important when you're working with literal equations and mathematical formulas that you are consistent in the case of the letter that is being used as a variable. So the V here is uppercase, it's a capitalized V. You want to keep it that way. And the L, the W, and the H are all lowercase, and you want to keep them that way. So the case does matter with your variables. And we can use inverse operations to rearrange formulas because they don't have to stay in the same way they're given to us, because the way it's given to us is it's solved for volume. But, you know, maybe we're given the volume and we want to figure out like the width or the height instead. So we can rearrange a formula using rules that we already have for solving regular equations. Okay, we just use those same rules about isolating a variable when you're solving a regular equation. An equation like where there's just one variable and then you have like operations and numbers, maybe something like 3x plus 4 equals 100, right? We know how to solve an equation like that. We use inverse operations. We do the same thing to both sides. Same thing here with the literal equation. We're doing the same thing, except there's more variables involved. So we just do the same rules, and our answer isn't a single number. It's going to be basically an expression. So if we look at this formula, V equals LWH, we want to isolate H. So we're going to change it. So maybe we have a problem. Maybe we have a problem where like they gave us the volume of a box, they gave us the length, and they gave us the width, but we don't know the height of the box. Okay, so we might want to rearrange the formula so we can just plug in the values that are given to us. So if you look at what we have right now, the L, the W, and the H, when they're all touching each other like that, that means they are being multiplied. All right, and so I'm going to ask you guys an interactive slide now. What is the inverse operation of multiplication? What would we use if we wanted to isolate H? That is a multiple choice Pear Deck slide. So you're going to go to your Pear Deck tab, and you're going to pick one of those four choices. How do you undo multiplication? What is the inverse operation of multiplication? All right. So let's take a look at what we came up with. As a class, 15 of us said division. One person said addition, one person said subtraction. And now that we have 18 for division and 1 for subtraction. Division is the correct answer. Okay, division is how we undo multiplication. Okay, so we're going to do that now. We're going to use division, and we're going to divide both sides of our equation, our literal equation, the mathematical formula for volume, by length and width. Length times width. It's the same exact thing on both sides. because when you work with an equation and you do something to one side, you have to do the exact same thing to the other side. It keeps it balanced so the value doesn't get messed up. And then if I simplify the right-hand side of that equation, what am I going to get? You guys have a choice now. Multiple choice. What did I just solve for? After I simplify the right-hand side, LWH divided by LW, what does that simplify to? I have 12, 13 responses. I'm just going to pick one. What one is it? Let's take a look at what we're coming up with. 4 of you say W, 11 of you say H. When you have a fraction and there is a common factor in the numerator and in the denominator, they cancel out. They divide out and give you 1. L divided by L is 1. W divided by W is 1. H is left in the numerator. H is the correct answer. H. Okay, so this is an example of rewriting a mathematical formula, which is a literal equation, so that it is solved for a different variable. Okay, your turn. Using the formula for a rectangular prism, still have the same mathematical formula. We're going to rewrite it, but this time we're going to solve for L. What would that look like? You're going to type me an equation and be careful to keep your V capitalized and your L, W, and H lowercase. Solve that equation for L. If you want to show division, you can use the slash on the keyboard. So you guys should be in your Pear Deck tab right now and not in the Google Meet tab. You should be typing something. So I'm seeing some correct solving as far as what you should do to both sides, but we're forgetting to keep the V uppercase. The V is the only letter that should be capitalized. L, W, and H should all be lowercase. Nice job, Alexis. Nice job, Angel. Angel A. Good, Bree. Good job, Arabella. All right, so let's go ahead and go over this example. So if we're trying to isolate L, solve for L, and L is being multiplied by W and H, I use the inverse operation of multiplication, which is division, and I divide by whatever it is it's going to make W and H divide out to give me 1. So I divide WH by WH. If I do that to the right, I do that to the left. The left-hand side stays as capital V divided by WH equals lowercase l. Okay, so this is a question for you where you're going to type me something. How is the process of rearranging a literal equation? That's what we've just been doing. We're rearranging literal equations. How is that process similar to solving an equation in one variable? An equation in one variable is something like 100 m equals 1000, or 4 plus x equals 20. How is the process the same? Okay, so let's look at some responses. A lot of you guys are off to a really good start. Have no idea, ask someone else. I think it's similar because you have to, the opposite sign, like if it's multiplication, then use division. I still don't fully understand. This is absolutely true, though. This is a similarity between rearranging a literal equation versus just working with a normal equation that you're used to. So we still have a, they are similar because, so we're getting started. Let me come up with some more words. This is nice. It's similar because it's doing something to both sides of the equation. Absolutely. They're similar because you still have to find a way to rearrange. That was good. They erased it. Okay. So you guys are coming up with some good ideas. I'm going to just show you one possible answer here is that in both cases, you are using inverse operations. And somebody mentioned that to isolate your variable. So you did come up with that. That's one possible similarity. Okay. Here is a mathematical formula. Y equals mx plus b. That is also known as slope-intercept form. You worked with that a lot in 8th grade. Y and x are variables. M usually represents the slope, where b represents the y-intercept. But in its pure form that you see right there, even though m and b represent numbers, we don't have specific numbers at this point. So we have 4 variables in an equation. It's a literal equation because there's more than 2 variables. I'm going to rearrange it so that it is solved for x. Think about what you would do. Think about if you were to solve an equation. You guys remember box and wall? I'm going to stop presenting for a second and just show you my screen. So you can pick one and then you could come back over to our Google Meet. And right now I'm showing you guys a piece of paper with some writing on it. Or if you don't know which one to pick, you can come back to our Google Meet. Right now we have all 4 choices being selected. So depending on how you have your Google Meet set up, you can always make the presenter's window larger on your screen if you can't see this. Okay, but one way to solve an equation is to do box and wall. You put a box around the thing that you're trying to isolate and a wall coming down from your equal sign to help you remember that you're doing the same thing to both sides of the equation. So x is being multiplied by m, and we're adding b. If this was just a regular equation and I was trying to solve it, wouldn't I get rid of the b first, right? And since it's being added, I use the inverse operation of addition. Inverse operation of addition is subtraction. I would subtract b to eliminate the b. And because I do it to one side of the equation, I would do it to the other side of the equation. And I could rewrite what I have left. So y minus b, I just have to rewrite it as y minus b because I can't combine y and b together. They're not like terms, they're different variables. And b minus b is 0, it goes away, so I'm left with m times x on one side and y minus b on the other. So if you look at your possible answers right now on your paired x slide, 3 of them include y minus b. One of them includes y plus b, so it can't be y plus b. It can't be a. A is not a possible answer. It's one of these other ones. So if you think it's A, change your answer. It's either going to be B, C, or D. Because I have to do one more thing to get x by itself. I'm not there yet. I'm almost there. Again, you could do box and wall. And m and x are being multiplied. So I'm actually going to divide both sides by whatever x is being multiplied by, which is m. M divided by m is 1. So I'm just left with x. And then what do I have on the other side? That's your answer. What does x equal? Which one shows y minus b, that quantity, divided by m? Nine of you have the right answer. 8 of you need to change your answer. So most of you have the correct answer right now. X equals the quantity of y minus b divided by m. B is the correct answer. Okay, and so this next slide is just going to show you that again. A little less work than I showed you on a Post-it, but they are subtracting b from both sides, and then they're dividing both sides by m. This is rewriting a literal equation. This one involved 2 steps. Okay, last interactive slide for you. How does the solution of a literal equation differ from the solution of a specific equation of the same form? So how are the two different? If I'm solving a literal equation like y equals mx plus b for x versus solving y equals mx plus b for x when I know that y is 4, m is 3, and b is 2. How do their solutions look different? What's different about them? So everyone should be over in your Pear Deck tab typing me something. How are they different? I have 7, 8, 9 people have started writing. When we change the place of some of the letters, the answer. So maybe, are you saying the answers are different? Something that is different is that in one equation, we aren't trying to find the exact answer. Okay. It differs because of the variables and the formula. If you do one thing on one equation, you do it to the other equation, does not work with these equations. Actually, it does. We are. So like whatever you do to one side of the equation, you should do to the other side of an equation. Doesn't matter if it's a specific equation or a literal equation. That is always true. You do want to do that. They both have different letters. They are different because the answer is different. I literally forgot what I just learned. Okay, well, good. You see, it's a video, so you could go back and watch this again. They're different because in literal equations, you're not really looking for that answer at that moment, but for a specific equation, you want to get the answer. Okay, I like that. We're trying to find 2 different things. Okay, so you guys are coming up with some stuff. Here's a possible answer. Unlike a specific equation, the literal equation solution is not a number. Okay, it's an expression made up of the letters that are involved in there, in that equation, representing the coefficients and constants in the literal equation. So one of them, your answer is a number. The other one, your answer is an expression with variables. Okay. That is the end of our lesson. And